Okay guys, so this is a short session on effect sizes, and I'm going to touch on something called G-power. So the very first question that you need to ask is, what is an effect size? An effect size is simply a way of quantifying the size of the difference between two groups. So this has many advantages over the use of statistical significance alone, such as your p-value. The effect size emphasizes the size of the difference rather than confounding this with a sample size. So this is the genuine size of the difference, as opposed to a difference in relation to how large your sample size is, which is commonly associated with the p-value. Now, a p-value or probability value is the probability of obtaining a test results at least as extreme as the results actually observed during the test, assuming that the null hypothesis is correct. So we don't want the null hypothesis is correct. We don't want it to be correct. So this is why we want the p to be as small as possible. We want the p to be below 0.05. And what that basically means is there's a 1 in 20 chance that your null hypothesis is true. So if you were to repeat the study 20 times, only 1 in 20 would you find a null hypothesis in that situation. So that's the acceptable parameters. But as I said, p-value is associated with sample size. So effect size in some ways are better because they're the genuine effect, the genuine difference between two groups. Just so you're aware, effect sizes come in all different sizes, different shapes and sizes. You can't see on the left hand side there, but that's your eta squared. It looks like an n, partial eta squared, p squared. D, that's your Cohen's d. There's an r there, that's your correlation, your Pearson's correlation, and that's your f squared. So there's a variety of different ways to express an effect size. If you're using SPSS, for instance, it uses eta squared. Cohen's d is very well known, and these are the indications of what is a small, medium or large effect size for each one of these indicators. So it's very important to know what effect size indicator you're using, and then use a chart such as you can get from Cohen 1992 to figure out, do you have a small, medium or large? You want a large effect is the best thing. So I want to move on to something called G-power. I'll go into all this stuff in more detail, but I just want to kind of show you the interface of it. You've got your F tests there, so your family of tests in this situation is your F, so that's your ANOVAs. You set your particular statistical test, your a priori or post hoc tests, and then I'll ask you a whole bunch of things there. So you've got your effect size, it's set to F. You can change that if you go into options. I'll probably go into that in a different video. Your error, your power, that's currently on default is set as 0.95. If you're working in the social sciences, you can knock that down to 0.8, so which is a 20% chance of obtaining a type 2 error. So that's as low as you can put that down. 2, that's the number of groups. That indicates let's say you had males, females as your grouping variables. You've got 2 groups. Your number of measures, let's say you had 2 groups, males and females, and you tested them over 3 points in time. Let's say, I don't know, it was some kind of attention drug or something, or some new exercise routine, whatever the reason. So you've got a 2 by 4. You test them 4 different times, and therefore you'd have a 2 by 4. So 2 by 4 contingency table where you've got male, female, and then 1, 2, 3, 4 measurements. That could be 3 measurements. So maybe you only tested at 3 points a time. Could even be 2 measurements, in which case it would be a 2 by 2 table. So your grouping variable is always your between. Remember, this is between factors. That's your grouping variable, and in this case your repeated measures is your number of measures. So 2 by 4. The other thing is the alpha. It's, as you can see, error probability is your alpha. That's always set at 0.05. That's default in social sciences, and you can pretty much then leave the rest as default. So what you really need to know when you're using G-Power is what's your family test, what type of test do you want to do, are you going to use an a priori or post hoc? Typically we want to a priori. So typically we use literature to find out what kind of effects do these kind of interventions typically have. As an indicator, we typically want to look at a medium effect size. So this would always be set default as a medium 0.25, a medium effect size. We don't want to be looking at a small or large effect. Typically it's going to be small, a medium effect size, and that will actually work out then what sample size you need. This is why we do power calculations. Is basically 2 things. We want to know, given this particular test with a medium effect size, with 2 grouping variables, 4 measurements, how many participants do we need? That's what we ask as researchers. This is saying we need 132 participants, and that will give us an actual power of 0.95. But I could set this lower if I wanted to, and I'll play around with this in a second just to show you the actual analysis. So bear with me, I'll get back to that in a second. So power, in plain English, all power is the statistical power is the probability of a hypothesis test of finding an effect if there is an effect to be found. That's the plain English way of describing it. The textbooks will say something like the power of a test of statistical significance is defined as the probability that it will reject a null hypothesis. A false null hypothesis is important to say. It's a false null hypothesis. So it's your power is the ability to detect and reject a false null hypothesis. You want to be rejecting a false null hypothesis. If you don't reject a false null hypothesis, that's called a type 2 error. So it's basically what it's saying is the probability of avoiding a type 2 error. Type 2 error is the non-rejection of a false null hypothesis. Remember, when we do statistics, we're trying to have a small p, and the small p is indicating what's the probability that your null hypothesis is true, effectively. Use the formal definition I stated at the start of this talk, but essentially that's what your powers is trying to say. It's the probability of avoiding a type 2 error. So if you're setting the power at 80, you have a 20% chance risk of committing a type 2 error. So you've got a 20% risk of not rejecting a false null hypothesis. So it's about the error. You want to be rejecting a null hypothesis. So I hope that's clear. I'm going to nip over now to the actual G-Power. Here it is. As I said, you've got your exact test, that's your Fisher exact tests, your F test, that's your ANOVAs. Your t-test is when you've got two conditions, and you've got things like your x-squared test, which is like your chi-squares, and your z tests. So in this particular situation, by the way, there's a huge variety of different types of tests that you can go through. So I suggest having a look, going through all of these. It's even got the non-parametric tests here, so it's pretty good. It doesn't have every single combination. There are limitations with G-power, so if that's the case, you might want to do a power analysis via something like R. But this is a very simple place to start if you don't have the computational mathematical background. If you're new to this, G-power is an excellent way to kind of work out power and sample size on the basis of what your predicted effect size is. So a priori is when you make a prediction beforehand, and your post hoc is, let's say, I don't know, maybe you're working in the NHS and you've already collected 150 participants. Now you've got that date, you've got that amount of participants. You don't have any control. The nurses basically gave you that data. You had no control. So you're now doing a statistical analysis, and you want to post hoc look backwards and work out what is the effect size given this particular sample size and this particular test that you're doing. But typically we want to use an a priori. So if you're doing anything with grants, you want to a priori predict. So going to here, I did say this 0.95. That's a 5% chance of having a false null. You want to set this as a 0.8. Which test do we want to use? We want to use, let's do a repeated between groups. So this is male, female. Let's say we had 3 points in time that we wanted to test. So keep the alpha as 0.5. That's a medium effect size. Power is 0.8 with a 20% chance of getting the type 2 error. And then we can just hit calculate. So basically it's saying you need 86 participants and the actual power is 0.80. You can change that effect size. There is ways of doing it. You can go into options or determine, and you can basically work it out through here. So I'll probably show you some advanced options with this, and I might even go into R and stuff like that. But that's all I wanted to do in terms of a very basic overview in terms of effect sizes and how to use G-power. Okay guys, I hope that was good.